Ever wonder how your phone recognizes your face or how Netflix knows what you'll like next? That's neural networks at work. Inspired by the human brain, these systems help machines learn from data. But don't worry, understanding them doesn't require a PhD. We're going to break it down simply so you can finally grasp what's behind the AI revolution happening all around you. At the core of a neural network are artificial neurons, tiny math functions that take input, do a calculation, and pass the result forward. Think of them like decision-making units. Each neuron connects to others, forming layers. The first layer takes in raw data, like pixels from an image, and the last layer gives the final output, like identifying a cat. Everything in between, that's where the magic happens. Neural networks are made of layers: input, hidden, and output. The input layer receives data, like numbers or images. Hidden layers do the heavy lifting, transforming and interpreting that data. The output layer gives the final answer. Each connection between neurons has a weight, which determines how much influence one neuron has on another. These weights are what the network learns and adjusts during training. So, how does a neural network learn? It starts with random guesses. Then, it compares its output to the correct answer using a function called loss. The bigger the mistake, the higher the loss. The network then tweaks its weights using a method called backpropagation, which adjusts connections to reduce future errors. Over time, it gets better at making accurate predictions. It's trial and error, at lightning speed. Training a neural network requires data, lots of it. For example, to recognize cats, you'd feed it thousands of labeled cat images. The network learns patterns: fur texture, ear shape, eye spacing. The more diverse the data, the better it generalizes. But too much training on the same data? That leads to overfitting, where the network memorizes instead of learning. Balance is key to building a smart model. Neural networks come in many flavors. Convolutional neural networks, CNNs, are great for images. Recurrent neural networks, RNNs, handle sequences like text or speech. Transformers, like the one powering ChatGPT, are the latest evolution, excellent at understanding context. Each type is tailored to a specific kind of data. Choosing the right architecture is like picking the right tool for the job. It makes all the difference. Neural networks aren't magic. They're just math and data working together. But their power is undeniable. They're helping doctors detect diseases, enabling cars to drive themselves, and even creating art. Understanding the basics gives you a glimpse into the future of technology. So next time you hear neural network, you'll know it's not just buzz, it's the engine behind the AI shaping our world.